So for problem number 16, this one says there are two planets, each with the same surface gravity, but planet 1 has a greater radius and is more massive than planet 2. Which of these planets has a greater escape velocity? What we know is that the surface gravity of both planets are the same, and this is the equation that we use for surface gravity, which is basically the force of gravity without the little mass. And then we've got the escape velocity equation, which I would love for you to make sure you practice that derivation a few times. It's the square root of 2gm over r. Now, these look pretty similar. The only problem is that we don't have an r squared here. So what we need is to include an r squared somewhere in there. So I am going to multiply r top and bottom, and this is all under the square root. So I end up with v is equal to 2gmr over r squared. Now, that doesn't change the problem at all, but what it does do is it allows us to plug in the fact that this gravity is the same for both planets. So if I plug in the g, then I can see that the velocity is equal to 2gr. And we know that obviously these are the same because the gravity they told us is the same for both planets, but the radius is different. So we want to figure out how the radius is going to affect the velocity. And in this case, since r is, even though it's under the square root, it's in the numerator, so if that increases, the velocity increases. And so planet 1 has a greater radius and therefore the greater velocity. So that would be A for your answer to number 16.